So we'll get started with slide 1. And hi there, and welcome to the US Web Design System monthly call for March of 2023. This month, we're celebrating Women's History Month with our logo in shades of orange, teal, purple, and pink, as well as St. Patrick's Day this week with shades of clover green, and the spring equinox next week with shades of cherry blossom pink. This week also featured both Pi Day and the Ides of March. Perhaps you did as I did and had a meal with both pizza and a Caesar salad. Slide 2. My name is Dan Williams, he, him, and I'm the USWDS product lead. And here on screen is my avatar: dark hair, blue sweater, collared shirt. Today, my physical self is wearing something very similar: a blue cardigan and collared shirt. I'd like to mention that when we introduce ourselves in these calls, you'll hear things like self-descriptions and pronouns. These help everyone share the same context and know a bit more about who we are, whether or not you can see us. First, I'd like to mention that we're recording this monthly call, so please refrain from turning on your camera. We will manually turn off any cameras to ensure the recording doesn't show us on camera. Unfortunately, while we are recording this call, we currently aren't able to share the video publicly. I'd also like to remind you that by voluntarily attending this Digital.gov event, you agree to abide by Digital.gov's community guidelines at digital.gov/communities/community guidelines. You can leave the meeting at any time if you do not agree to abide by these guidelines. We've posted a link to the community guidelines in the chat. If you're in the Zoom app, you can use integrated live captioning by selecting the CC button on the bottom of the screen. If you prefer live captioning in a separate window, we've posted a link to the live captioning in the chat. We'll be posting other links and references into the chat as we go along, and I encourage you to ask questions in the chat at any time. I also noticed that occasionally folks will raise their hands. I'm not able to answer questions from raised hands during the presentation, but if you ask a question in the chat, there might be someone who can answer your question. So yeah, if any member of our team can answer your question in the chat, we'll do so. Otherwise, there will be time for questions and answers at the end of the presentation. Also, be sure to introduce yourself in the chat if you're comfortable with that. It is nice to know who's here, and it's good to have you here today. So also, though, for folks who might find the chat distracting, you're welcome to close or hide the chat window during the main presentation. You can reopen it later during the Q&A session at the end of the call. So thank you. Thanks for listening to all of that. And with that, let's get started with slide 3. So what's our agenda for today? It's a pretty simple agenda for today. First, we'll take a quick look at some product updates at the most recent design system releases. And then we'll spend the rest of our time talking about cognitive theory with a little presentation that I'm calling Making Sense. And at the end of that, we ought to have some time left for Q&A, almost certainly. So let's get right into it. Slide 4, some product updates. Since the last monthly call, we've published both USWDS 3.4.0 and USWDS 3.4.1. Due to a sequencing error, my fault, in our release process, we inadvertently left a couple new features out of USWDS 3.4.0 when we released it. So we quickly released a patch version, 3.4.1, that includes all the features and bug fixes we intended to release in 3.4.0. So if you're interested in 3.4.0, just go right ahead and move right to 3.4.1. Slide 5. So here's a bit of what you get in this feature-filled and bug fix-filled release. So first, since we no longer directly support IE11 post USWDS 3.0, as of USWDS 3.4.1, we no longer reference two types of font files, WAF and TTF font files, in our font face rules. We don't need to anymore. We only reference the modern font format for web fonts, which is WAF2. This means if you self-host a custom font in your project that only has WAF2 files, our built-in font face generator will work for you now. It was time to make this change. But if your project still has to support older browsers, we have a new setting that you can pass in your USWDS settings that will output the WAF and TTF fonts as well. This release will also improve contrast of incomplete step indicator steps. It will allow full page width headers. It will remove the grid dependency from the USA banner package, making that package a lot smaller if you're implementing that package a la carte. It'll properly vocalize secondary navigation items. And it will improve the wrapping of external links and the external link icon. Slide 6. In addition, USWDS 3.4.1 will also allow date pickers inside modals. There were some things that kept some of these more complex interactions from initializing properly in a modal, and that's fixed now. We're also improving the URL display for links from our new in-page navigation component. We now allow any spacing unit in alert padding settings. There was some weird math going on behind the scenes that was preventing some legitimate spacing tokens from going into some of our settings. And we also fixed a broken outline 5 utility. And finally, on our website, in the patterns section, we expanded and improved our gender identity and sex patterns and guidance. Slide 7. And that is USWDS 3.4.1. And that is out now. So look for it wherever you get USWDS packages. Slide 8. So this month, I'd like to take a little step back and discuss something that I've often considered one of the fundamentals of design work, learning a bit about how our brains make sense of the world. After we published our pattern guidance, we got some good feedback that while we were starting to get into patterns and interactions, we still didn't have any information about what you might consider the general rules of UX, and we definitely should. And as I was thinking through the kinds of things that we might consider general rules of UX, I kept coming back to some of the ideas we'll talk about today. And as the USWDS team starts to think about how we want to address general rules of UX, we might start with some observations about human cognition that are more than 100 years old, but continue to be proven by neuroscience today. So today, I'm going to try to take a swing at trying to make something that's interesting to me, interesting to others, in making sense, attention, grouping, and decisions. Now, I am an enthusiastic practitioner. I'm interested in the topics I'll discuss here, but I am not a psychologist, nor am I a cognitive scientist. If you are, and I say something that doesn't sound right to you, call it out in the chat, and we'll be sure to try to discuss it at the end. So let's get started. Slide 9. There are all types of angles on design work when it comes to the products we're all a part of, websites and digital services. But this also extends into things like print design. There's visual design, there's product design, interaction design, content design, service design, UX design, and the tenets of human-centered design that connect all of these. Slide 10. These are ways that we all contribute to the process of design, to the process of intentional decision-making, whether we're helping to make these decisions or supporting the ways we make them or the ways we implement these decisions in our products. Slide 11. By and large, at the end of the day, we are all designing for people. Sometimes we design a little bit for algorithms and a little bit for robots, but our primary audience for most things is people. Our end users are typically the humans that we center our design process around. Slide 12. So one of the things that connects many design disciplines is human interaction. We're creating tools and spaces, predominantly digital spaces, for people to do things. So one thing I'd like to assert is that in our world of designing for human interaction, we designers are engineers of human attention. Just as electrical engineers deal with electricity and structural engineers work with materials like steel, concrete, wood, plastic, and water, human interaction digital designers, human interaction designers, to use a broad term, deal with human attention, conserving, supporting, sustaining, and rewarding the attention of the people who use our sites and services to do something that they need or want to do. Slide 13. Just as electricity, steel, and water have their own properties, characteristics, and physics, attention is also a resource with its own properties. Slide 14. So what is attention? Attention is the focus of awareness, following one stream of sensation over another. Of the countless sources of sensory input available to our bodies, coming in all the time through our eyes and ears, through our skin, mouth, nose, attention is the stream we choose, consciously or unconsciously. Slide 15. Attention is coordinated in the brain, and it is in part directed by the sense of self that we hold in our brains, which we might call the mind. We can consciously direct our focus. We can direct our attention in different ways, in different physical or mental directions, based on a conscious goal or an intention. When we're goal seeking, our intention directs our attention. For instance, if we want to make breakfast, we might direct our attention, our sensory focus, toward navigating our body to the kitchen, asking ourselves what we want to eat, then checking the cabinet for cereal, the refrigerator for milk, and the shelf for a bowl, and so on. For many of the tasks we attend to in our day-to-day lives, this type of attention, of using our senses and our memory to follow a chain or flow of navigation and decision-making, is simple and frictionless and takes relatively little energy. Slide 16. And this is good, since it turns out that we humans have somewhat little energy to spend on decision-making. Our brains have evolved to become extremely efficient at navigating huge amounts of sensory information and accomplishing tasks. And the primary way our brains are efficient, can save energy, the primary way our brains do this is by forgetting. and ignoring. We are very good at forgetting and ignoring. Slide 17. Attention is as much about ignoring as it is about focusing. We spend energy on attention, so we don't spend it trying to understand everything that's happening around us. This act of actively working and processing information and forgetting stuff, taking it in and forgetting it, is the job of what we call working memory. Working memory is not entirely dissimilar to what we think of as RAM, or random access memory, that we have in our computer. A type of buffer memory that helps us make the decision we need to make at the moment and then move on to something else. We don't typically store vast quantities of sensory data directly in our brains the way a digital camera might. What we store in working memory is only stored for somewhere between a fraction of a second to just a few seconds. So notably, our brains have separate areas for processing visual working memory and language-based working memory. This is also true for deaf people, for people who use sign language. The message content of sign language is processed differently from other visual stimuli. And language-based working memory is often something that you might hear called an echoic loop. So throughout the flow of any action, our brains use the perceptual or orientation working memory with the language working memory to help make some decisions. For example, the message let the dog out, and the image of a dog near a door might lead to a plan to open the door. This creates an intention, which directs the next step in the flow of attention. Let's navigate to the door. Let's find the handle and turn it. Okay, the door is locked. Don't panic. Let's use a bit more working memory and attention to unlock the door and continue with the flow. We've got this. In another hour, will we remember whether the door was locked when we let out the dog? Probably not. Will we even remember it in another 10 minutes? Probably not. Every brain is a bit different, but this tends to be the case. It can take real effort. It may even be impossible to remember something like what you had for dinner a week ago. Slide 18. Our brains are optimized to be just-in-time systems. We acquire and store just enough energy to get us on to the next thing. And only over time, if there are significant internal or external consequences to a particular action, do we begin to form longer-term associations that we call long-term memories. Slide 19. In fact, if we take a second to look around the room that we're in, we can easily recognize it as our room, as a familiar room. But if we were asked to draw or describe specific features of the room, very specific features, like whether there was a specific shirt or a book here on this surface or another, or certainly something like, I don't know, how many stripes are there on the rug? It might be hard to conjure those specifics. We only get the gist of a situation, and we selectively use our senses and our attention only when we need it to draw out specifics. A principle of cognition is that the world is its own memory. We are beings that are built to live in a kind of consistent, coherent, and continuous reality. It's important that we can trust that if we have a chair in our room, for instance, it'll be there until we move it. It doesn't just disappear. The world is its own memory. Its continuity and consistency are the foundation that we as humans depend on to work properly. We don't remember everything perfectly up in our brains. We remember just a gist, and then we sample in and out to get the specifics we need to do what we need to do. Slide 20. We're constantly toggling from gist, this kind of general idea of what's up, to the specific thing I need to do, trying to maintain a general model that can allow us to navigate to something specific when we need it. The relationship between gist and specific is what allows us to use our attention and our working memory efficiently and effectively to navigate a world of like infinite information without requiring infinite resources. Slide 21. Imagine that you've been given an unusual task. Let's enter an unfamiliar building and find a jar of honey. Now, if you were in your own home, you might know where you'd look. It wouldn't take much energy. It would even be easy to give directions to a neighbor trying to find a jar of honey in your home, even if they've never been inside it. Now, let me describe two very kind of terrible buildings that would make this task difficult. The first is what we might call the random warehouse. It's just a big open warehouse with shelves and shelves of different items arranged randomly. Where would you look for the honey? What strategies might you use to find it? Is there any gist you could use to make of this situation to help you out? Probably not. You just have to look thoroughly and monotonously from one shelf to another, trying to scan for this specific jar. It would be a big task, and you might give up. It's a lot of work to go from item to item. It's tedious and time-consuming. There's a lot of looking and little decisions. There's no organization. How much do you really want that honey? Slide 23. And the next scenario might be even worse. Let's call it the mystery house. In the mystery house, it looks a lot like the type of house that you might recognize. It has rooms like kitchens and bathrooms and living rooms, but nothing is where you expect it to be. The kitchen cabinets seem to be full of laundry. There's a stairway that leads nowhere. It has the appearance of order, but it's completely out of sync with your expectations. While the first scenario, while the random warehouse feels lazy and tedious, this one actually feels cruel. It's encouraging us to see organization, to make a gist, and then kind of punishing us for doing it. I don't know about you, but I'd give up on finding that honey in the mystery house much faster than in the random warehouse. It actually takes more energy to work against bad organization than against no organization at all. Slide 24. Our minds need consistent, meaningful organization to make sense of the world. We need to be able to move from gist to specific with as little energy as possible. And our minds are built to do just this, create gists and spot differences. Slide 25. For more than 100 years, scientists and psychologists have been studying the concept of like the gist. And it has a fancy German name as well, Gestalt. Gestalt, which might also be translated as like wholeness or form, is a concept explored in depth by a Czech psychologist whose name is Max Wertheimer in the early part of the 20th century, around the time of the First World War. Gestalt theory proposes that we make sense of the world through the perception of wholeness, and that this wholeness is a kind of model. The model is different from being simply the totality of its constituent parts. Wertheimer, pardon me. Sorry about that. My computer just did a weird thing. Anyhow, we were talking about, because of what my computer did, can I just confirm that my screen is still sharing?
Yes, it is, Dan.
Okay, thank you. It's just kind of a weird thing on my screen. Sorry for the distraction here. That actually plays well into this idea of distractions, which we'll get to as getting you out of your flow. Anyhow, we were talking about Max Wertheimer and about this idea of Gestalt and wholeness. Wertheimer helped define the field of cognitive psychology, which was focused on attention, language use, memory, perception, problem solving, creativity, and reasoning. This is and was sort of distinguished from something from other fields like behaviorism. Behaviorism, which saw some of these cognitive concepts as almost like fundamentally unknowable, or at least unobservable, and focused instead on what can be more easily observable, or behaviors. I think it's important to say that when it comes to understanding how we live and think and act, like there may be no like either or here. Both behaviorism and cognitive psychology contribute to what maybe ironically we might consider the gestalt or like gist of human psychology. Slide 26. Gestalt psychology proposes that our minds function not as like recording devices or accumulators of data. We do accumulate data, but we're not a big like cloud computer, like sucking in massive amounts of data and like processing through massive amounts of data. What our brains store more effectively are models, organizational concepts that allow us to store group information. It's almost like a kind of compression algorithm that allows us to avoid data redundancy. We don't need to know what every single iteration of an apple looks like. We only need to hold the concept of an apple and then sample the details from case to case as our intention and our attention demands. Slide 27. Gestalt theory proposes that our minds are built to form groups, that we perform certain kinds of grouping automatically. And cognitive science has ample evidence that this is true. I'd like to show some types of grouping identified by Gestalt theorists. You may have some familiarity with them already. They're called the Gestalt principles of grouping. These are visual examples, but grouping is not exclusively a visual phenomenon. Think of how we perceive something like rhythm in music. We hear or feel the rhythm as a complete structure, as a wholeness, instead of simply a sequence of individual unconnected notes or beats. Today we're going to look at 7 principles of grouping. This is a living field. Some of these principles are the originals identified by the original Gestalt theorists, and some have been added by subsequent studies. Slide 28. The first concept is somewhat meta, and it's the concept that we want to find meaning by grouping. We tend to group stimuli in a way that preserves and enhances some type of meaning, preferring the simplest explanation. This is called the principle of pregnance. And pregnance, whose exact translation is something like precision, we might also think of as elegance, in the way that a solution to a problem might be considered elegant. We're inclined to find an elegant explanation to describe a collection of data. A common example of this principle is anthropomorphization, the way we might see like a face in a cloud, an elephant in a cloud, or a face in like the splotches of your toast. In a more practical sense, this helps us orient to unusual perspective or lighting. It helps us see a cat in a curving pattern of shadows on the bed at night, for instance. Or in the example on this slide, we can see what might be considered a complex pattern of arcs and intersections. But the principle of pregnance predicts that most of us will eventually interpret this image as 6 overlapping circles. Slide 29. The second grouping principle says that we're inclined to group together items that have similar characteristics. This could be color, shape, size, texture, orientation, etc. This one is called the principle of similarity. On this slide, we see a 7x7 grid of gold circles. And 9 of them, I believe, 1, 2, 3, 4, 5, 6, 7, 9 of them are blue. We see those blue circles as somewhat as connected to each other, as having a relationship that's formed by their similarity. Now, in something like a website, like an example of the principle of similarity at work could be similar colors and shapes for things like links or buttons, the same sort of fonts or headers. One of the things about the principle of similarity is that it forms groups that are not necessarily influenced by proximity. Because they're formed by a similar characteristic, you could have similar things on in different parts of the visual field that are grouped together. Slide 30. Speaking of proximity, third grouping principle says that we're inclined to group together objects that are closer together physically. And this is called the principle of proximity. On this slide, we see that same sort of 7x7 grid of gold dots, but the third column is removed. So we see two groups of gold dots separated by a space. This principle of proximity is something that you might see on a web page, like in sectioning or in items in a navigation, through the use of spacing and white space to visually collect different groups of meaningful things and separate them from something that's different. Slide 31. The fourth grouping principle says that we're inclined to group together objects that are found in the same closed region. This is called the principle of common region. Again, we see the same group, 7x7 group of dots with the same grouping as before, like they were grouped into these two, essentially these two columns. But we see the principle of common region with a white outline that surrounds essentially a row of these dots. One of the things about the principle of common region is that it can connect sometimes dissimilar items, and it has a really powerful effect that's stronger than other forms of grouping. That you can see this relationship, the relationship between the common region elements seems very, very strong, and almost is a stronger effect than that of proximity. Slide 32. The fifth grouping principle says that we're inclined to group together objects that are moving together. And this is called the principle of common fate. Now I'm gonna show an animation, so be ready for it. Here we see that same group of gold dots with all the different groupings that were before, but a whole section of them slid off of the page. And because they all slid off the page together, they're naturally grouped together as being related. Now, with the design system, we try to reduce animations. We don't have a lot of animations in the design system. They can be kind of distracting. But a very, very common interaction that folks have that shows the principle of common fate is simply scrolling through a website. As we scroll through a website, we see pretty much everything working together, all the things that are relatedly part of the website working together. Things that don't scroll together, something like a sticky nav, are particularly noticeable as well. There's a meaningful connection to the things in the sticky nav and a meaningful connection between everything that's scrolling together. This can sometimes begin to explain why it can be distracting and disorienting to have something like parallax scroll, where different things are scrolling at different speeds. It breaks the website up into more moving pieces, more groups than are meaningful and sensical. Slide 33. The fifth grouping principle says that we're inclined to group together objects that follow a common path, and we favor smooth or curved paths over those with unexpected changes in direction. And this is called the principle of continuity. And if we look at we look at this collection of gold dots on this slide, there are different ways that you might interpret what is happening with these gold dots. But the most common interpretation of what might be happening is that you would see this as two arcs of gold dots that are intersecting. You tend to read it less as a couple gold dots that are going up and then radically changing direction and going down, and then and going up and going down again, making sort of sharp turns. We want to group together things that feel like they change continuously. The principle of continuity is that gradual incremental change improves group identity. In a large scale sense, this kind of like builds trust, that things are happening in the way you predict them to happen. Small and incremental change. Something like common path might also be used in a design system component like a step indicator or in a process list, where we see elements in the component moving along a common line or a common path. Slide 34. The sixth grouping principle says that we're inclined to fill in blanks to perceive a complete object whenever an external stimulus partially matches that object. That we're inclined to fill in the blanks to make whole objects. And this is called the principle of closure. On this slide, we see 3 large gold dots and a part of a gold dot. And the way we typically perceive this group is that part of a gold dot that extends off the side of the screen, we see it as another dot that might continue further on. We just don't see all of it. We don't see it as just a random section of a dot. We see it as a part of another wholeness. Now, this can often be used in design as an indication that more information exists off screen or outside of the existing frame. Sometimes folks will use this in like a slider or a carousel, but also in standard up and down vertical scrolling. If you see just part of something, you're inclined to want to kind of push the screen or move it to see the rest of it. Now, there's an inverse to this effect, to the principle of closure. That's something called the illusion of completeness. And that's when there might be some more content off screen, but you don't see anything that is a partial. You don't see anything that is partly on the screen and partly on the next. That might give your brain the idea that everything you see on the screen is the complete wholeness. And then you're less inclined to want to scroll. You might have seen that on some websites or in some applications, where it's like, it takes you many times to use it to be like, oh, I could scroll this and there's something more off the page. Slide 35. So just as our brains are inclined to group elements by characteristics that imply a group identity, we're equally inclined to identify differences between a single element and other elements in the same perceptual field. We're equally inclined to identify groups of one. You could think about this perception of difference as something like contrast, since contrast is a measurement of the degree of difference. We're all familiar with color contrast and what's required by Section 508 in WCAG, which is a difference in luminance, a perceptual difference in luminance that helps isolate individual elements. But there are lots of ways to perceive difference. When there are groups of one with sufficient difference, this result is something called the pop-out effect. In the pop-out effect, the element that is different pops out of its context and begins to capture primary attention. Often only after we attend to the element isolated by the pop-out effect can we attend to other groupings and other characteristics in an environment. The pop-out effect can be a powerful driver of attention, and as such can also be super distracting. Sometimes the power of the pop-out effect can overwhelm attention and capture all the resources in your working memory, at least until it can be actively ignored. Think of maybe a notification on your computer that sort of bounces. It's just bouncing there. You keep looking and you get distracted and you lose your train of thought. That thing is popping out. So I'm going to show a few kinds of differences, characteristics that can trigger the pop-out effect. Some are more dramatic than others, and all of them depend on the degree of difference. Slide 36. And in most of the slides that follow, we see a similar sort of like 7x7 grid of, instead of circles this time, we're looking at dashes. But slide 36 shows a change in luminance. And at least when you're dealing in the US web design system, like if you're changing the luminance or sort of brightness of an element, you tend to need a color grade difference of about 50 of what we might like. Is that that is like what indicates like WCAG AA. WCAG AA contrast is the difference you need to really make something pop out as different from its environment. Right here we see, I believe it's all the colors here are gold 70 are the sort of darker color bars, and gold 20V is this one bright color bar up sort of in the middle, and that's the one that pops. If you notice, there's another color bar that is just a little bit brighter, only maybe 20 grade difference on the bottom row, and that one, oh, that one doesn't pop as much. So you need a certain amount of difference to trigger the pop out effect, and perhaps unsurprisingly, that color grade difference of 50 that's meaningful to WCAG is the difference in luminance that you really need to trigger that pop-out effect. Slide 37. You can also trigger that pop-out effect by differences in size. We see the same grid, the 7x7 dash grid, and the first thing that probably pops out is one of the dashes is kind of tall in the second row, and that one pops out pretty effectively. But we see also in the fourth row, there's one that's a little bit different. That one doesn't pop out as much. So pop out by size is also something that you can trigger. You can also trigger pop out by shape. In this 7x7 grid, one of the elements is a dot, and that dot is really quite different. The shape of the dot is very different from a dash, so it really sort of dramatically catches your eye and shows itself as different. It's almost entirely impossible to see on this, but one of these dashes is shaped like a pill and has rounded corners, and that change in shape is pretty much so subtle and so difficult to notice that it doesn't really pop out at all. It's a distinction that has no impact. Slide 39. You can also sometimes a gentle amount of pop out you can get through a change in hue. And in this grid, we see the same sort of gold 20 colored bars. For folks who aren't familiar with the design system as much as I am, gold 20 is a color in the design system color system. Gold is the color, and 20 is essentially the luminance. There are 3 other colored bars in here, and I might argue that none of them really pop out a lot. A little bit. One of them is green, one of them is pink, and one of them is blue. But if you're trying to capture attention with a change in hue, it really needs to be combined with something else to be meaningful. It should be combined with a change in size. It could be changed with a change in shape or a change in luminance. Hue itself is not a reliable way to trigger pop-out effect. Slide 40 shows a change in alignment. So we see that same grid. One of them has a sort of big difference in alignment, and that one kind of pops out as different. A small change in alignment pops out a little bit less. When there are differences in alignment, that that can trigger that something is different, and you may not intend to have a difference. Sometimes when we're reading text or have different elements aligned on a page, we tend to use a grid to align things together to minimize the amount of difference between sections, so we can concentrate on the important differences. Slide 41. Another example of pop-out is orientation. We can see a strong 90-degree change in orientation in one of these elements. We can see a teeny tiny one if we look in another. Big changes are more likely to trigger the pop-out effect. And finally, slide 42, outline. I would argue extremely effective in triggering the pop-out effect. If we go back earlier to one of the Gestalt principles, a principle of common region, we can see that we are describing a common region of one, and it really jumps out. So we see that things like outlines, like focus outlines, are super effective in drawing our attention to where a noticeable region is on the page. Slide 43. Now, our brains are really good at both grouping and finding key details. Part of our job as designers is to use what the brain is already doing all the time and reinforce that activity with meaning. Our job is to understand the intentions of the people who use our sites and services and create interactive environments that are organized in such a way that folks can easily orient themselves and make a reliable guess about what they should do next. Slide 44. As I was writing this presentation, I thought that an alternative title for it, instead of making sense, might be, what do I do now? Since this is the driving force behind almost like every interaction, big and small. How do I make the next decision? Where do I focus my attention now? You come to a website, what do I do now? What's most important? What do I choose to do first? Slide 45. Each decision that a user needs to make in any process uses up a little bit of working memory. And the total amount of working memory we're using at any one time is something we call cognitive load. And when the cognitive load reaches the max of our working memory, that's when we get frustrated and give up or get mad or just need to take a break. Slide 46. People have all their free working memory available to a task only on the best of days. Most days, there are plenty of other things happening that are literally taking up space in our memory. Distractions, stresses, and fatigue all add to our cognitive load, leaving even less available for understanding how to do something new. Like, I've given plenty of presentations. I know how to read my script and look at slides. Something flashed on my screen. Some windows changed. I got distracted. I lost like everything. I forgot where I was. I felt like I forgot how to use a computer for a second. Like, these kinds of distractions, these kinds of things are really meaningful and make a big difference in how we're effectively able to act. So when possible, we want to structure our experiences so that each individual step a user takes is as meaningful and as simple as it can be. Slide 47. Using meaningful groupings, grouping things together and imbuing those groupings with meanings is like creating a navigable decision tree. The first groupings we notice are our first decision. In which grouping should I focus my attention first? Then we sample a detail from that grouping. Maybe it's one of those little things that modestly pops out, like a header or a bit of information from it. Like, what's the purpose of this grouping? Did it confirm my assumption about the purpose? Does it have the information I'm looking for? If so, we continue. If not, we go to the next grouping. Then, when we find a relevant grouping, we look inside it to make our next decision. At each step, we want to limit the amount of decision-making we expect of the user. Studies show that people have a much harder time if they're trying to decide from between more than about 5 to 7 choices. More than 7, You may want to reorganize the groupings so that users can make a simpler choice first. Slide 48. And of course, these groupings should be meaningful. Remember the mystery house example from before. Structure that gave the appearance of meaning without meaningful organization. It was even more frustrating than no structure at all. So beware of miscellaneous grab bag sections in your sites and services, like a sidebar that contains like half a dozen unrelated modules. Slide 49. Now, using meaningful groupings helps to help users easily get the gist of an interaction is drawn from research into the visual parts of the brain and came out of studying visual design. But the concept can also inform how we design for blind users and is very applicable to understanding the needs of folks who are colorblind or use screen magnifiers. And it's also critically important to content designers. It's not just for visual design. Slide 50. Even though blind users navigating our sites with screen readers aren't perceiving our page groupings visually, many of these meaningful groupings still exist and are in fact more explicit and important for screen readers. Some of the most common visual groupings are defined in our markup with semantic HTML and ARIA roles. Markup semantics, which ARIA extends, give canonical names to common groupings: header, footer, main, body, section, etc. These are all examples of meaningful groupings available to screen readers. In fact, semantic HTML and ARIA roles can give a great hint to designers about the types of groupings they should make sure are clear in their visual designs. Blind users certainly use focused attention and working memory and have limited cognitive load, just like everybody else. Just as sighted users might use their eyes to scan groups and common elements, screen reader users can and do similarly scan or browse pages. Technology should enable the same type of gist detail scanning that sighted users do with their eyes. Other perceptual differences like color blindness and limited field of vision highlight the importance of layering methods of grouping and difference. Slide 52. And finally, many of the principles of grouping and distinction are critically important to content design. Chapters, sections, paragraphs, sentences, and lists are common structural groupings that are considered the building blocks of writing. The techniques of plain language filter these building blocks through the lens of cognitive load and simplicity, like use clear headings, keep paragraphs short, use lists instead of paragraphs when possible, stick to the point, use parallel structure to highlight the differences between clauses. Each of these guidelines helps users easily scan to find the meaning of a group of text. In so many ways, our overall grouping structures of layout and design exist to support text. Our layout grouping should be informed by our content, and our content should itself be meaningfully grouped. Slide 53. At the end of the day, all of this somewhat academic content is in the service of helping us better and more completely understand the people we serve. For us designers, none of this information is useful, independent of user experience. No design is better because it better implements Gestalt groupings. No designer is more effective because they think of themselves as an engineer of attention. A design is better because it addresses user needs more effectively. If information about some of what we understand to be fundamentals of cognition helps us stay engaged with our audience, and it helps us understand what kind of design decisions to try when we have a problem, then that, I hope, is also something of value. So, slide 54. For more information, you can find a number of good resources online. I think a lot have been in the chat as well. I see we're running late. I'm sorry. Here are a few things that you could search for if you're interested in more resources. The Gestalt Principles of Grouping, Max Wertheimer, Cognitive Psychology, Attention, Cognitive Load, Working Memory, Unconscious Pop-Out, and Selective Attention Test Video. This is a great one. Google, check it out in a search engine, find the result, watch it as knowing as little as possible going in, and it's super interesting.